Here we go. All right, so bell work number 10, it says, find the volume of these figures. What did we say that this soup can was again? Cylinder. Good. Okay, so take a look at your little half sheet, or these formulas are on the back of your review. What is the volume of a cylinder? What is that formula? Come on, take a look at it. Bless you. Volume of a cylinder. What's the formula?
Area equals.
Well, we're looking for volume.
Volume equals base 1 and plus base 2.
I think you're guessing.
I think I got it right.
Alex, what's the formula? Do you know? Volume of a cylinder. Come on, guys. Ty, do you see it? On the half sheet? Do you have a half sheet? Just looking for the formula. Do you know what it is? What is it? Pi r squared h. Okay? So pi is a number. We'll keep that the same. Radius. Somebody let Blake back in. Radius. It says they give us the diameter. How do I find the radius? Sean, how do I find the radius if they give me the diameter? Divide by 2. So 6.5 divided by 2 is 3.25. That is my radius. Okay? So 3.25 squared times my height. Height, they say, is 10. So multiply by 10. Everybody on your calculators. Multiply that together. Ontario, I think there's a calculator behind you. Blake, can you let Alicia in, please?
What is that, a 3?
3.25 squared times 10. What are we getting? Did you find one?
Yeah.
Oh,
I don't know why I'm supposed to
105.625.
I don't think so. Did you forgot to multiply by pi?
Pi.
What'd you get, Ty?
Is it 10.6?
No? What'd you get?
I got 331.83.
Yes. 331.83. How do I label this?
200.
Centimeters cubed, because it's volume. Now, I know your problem, William, was that you forgot to multiply by pi. I'm not sure what you got. What did you say it was? 10 point something you got? So take pi now on the calculator times 3.25 and hit the x squared button and then times 10. And what, hit enter? What'd you get?
33.98.
Did you multiply by 10? The height? Yeah. Don't forget the height. So if you multiply by 10, then you'll get 331. Okay? All right, let's take a look at the next one. So this looks like a barn silo. Are you familiar with a silo that holds grain on a farm? Fills all the way up, and it's like the food that they feed cattle, pigs, or whatever it is they have. So we call this a composite figure. So the volume of this figure is made up of two different things, okay? We have this on the bottom half, and then we have this other figure on the top half. So the bottom figure, what is this? What would you call this? What'd you say? I think you're right. What is that? Doesn't it look kind of like the soup can, that bottom half? Yeah, this is a cylinder. So that's a cylinder. What about this top half?
Half a sphere.
Half a sphere, which we call a hemisphere. Half a sphere is a hemisphere. So the volume of this figure is the volume of a cylinder plus the volume of a hemisphere. Okay? Volume of a cylinder is our same formula as what we had for the first problem. Pi r squared times height. Volume of a hemisphere is the volume of a sphere, and then we take half of that. So volume of a sphere is 4/3 times pi times radius cubed, and then I'm going to multiply that times 1/2 because I only want half of the whole sphere, not the whole thing. Okay, Ontario, you with me? Do you have this? Okay. After I do this, I'll look for it, okay? So here we go. Pi r squared. Here's pi. Radius. Did they give me the radius? Is this 12 inches the radius? Looks like it's a line that goes all the way across. Is that the radius?
Yeah.
No, that's diameter. And Sean told us earlier, diameter divided by 2 is equal to the radius. So 12 divided by 2 is 6. So my radius for this problem for the cylinder is 6. So that's going to be 6 squared times the height. What is the height just of the cylinder? Blake, what's the height of my cylinder? 13, yes. All right, so that's the formula for the first one. Plus, the second one, I got to substitute numbers in. So I got 1/2 times 4/3 times pi times radius cubed. All right, well, what is the radius of my hemisphere? I almost said semisphere. What is this radius? What is the radius? Is it possible it would be the same as the radius of the cylinder?
Yeah.
Yeah, it is. So if I put the radius down here at 6, but if I move it kind of in a counterclockwise position, that's still going to be 6 as long as I am going from the center of the circle to the edge. So I multiply this second part of the formula by 6 to the 3rd power. Okay. So equals, take pi times 6 squared times 13. I think the, let me take a look. Should be the, no, this isn't the right one. There should be another packet. Yeah, I think it's that one. So what do we get? 6 squared times 13 times pi. Who's got an answer?
6 squared?
Pi times 6 squared times 13. Guys, come on. We're just talking about punching numbers in a calculator. Come on, you can do it. Pi times 6 squared times 13. What'd you get? Say it again.
I said 468.
I think it's bigger than that. Did you get something? 1,000 some?
1,809.557.
1,000. How much?
1,809.
Say it again. 1470 point 2265. 265. All right. I believe that's correct. So did you take pi times 6 squared times 13? And you didn't get that number? Try it one more time. All right, while she's trying the first one, somebody else, I need you to multiply 1/2 times 4/3 times pi times 6 cubed. Everybody should be punching in these numbers.
What do numbers ever do?
1/2 times 4/3 times pi times 6 cubed. Ontario, we are on day 10? Day 10.
I think it's this one. I think I just don't have that page.
Huh.
This one says the Tuesday test tomorrow.
Okay. That's odd. Times 6 to the 3rd power. So that's 6 caret 3. Should be 400 some, I believe. Has anybody got that answer? Evelyn, do you have that by chance?
Well, I'm confident to put this one in the calculator. You put pi first? Pi first?
No, don't have to. 452 point what? 389. Okay, so if I add these together, 1470.265 plus 452.389, you should get something like 1,922.654 inches cubed, because we're talking about volume. Okay? Does everybody see how you need to take the volume of each of those separately? All right, let me take a look. This one? 12B. No, that's not it either. No, that's circles. You got all the stuff the other day, right? That was in there?
Yeah.
I thought you.
I was just working on it the other day.
I know, I thought you were too. 12B. Yeah, that's 6163. All right, so now take out your review packet. Review packet, and I think we're gonna go over some of these together. It would be in this orange one. Blue. Do you mind if I look? Might have another one. Let's see if I got another one. All right, so go ahead, get started on the review. I'm gonna go over some with you, but I'm gonna look for a packet for him. So it might take me just a couple of minutes. You do have the half sheet with the formulas. You will have that. No, we're not doing that right now. Come on. Put all of that away. All right. Huh? Can you what? Yeah, see if there's one just to the right of the crate on top. Okay. I want to start going over to the right. Yeah, right there. If that's it, does it say review?
Is that this?
Yeah. All right. Here we go. It's still recording. Could be good, could be bad. All right, review. Okay, we're going to start to go over these together, but I need your help in talking to me about what the formulas are, what the figures are. So let's take a look at number 1. Number 1 says, find the area of each of these figures. Is everybody with me? We got the review. Okay. Number 1, first page. The review is separate. Okay. What is the name of that figure? Because we have to kind of identify that figure before we find the right formula. Does anybody know what that is? Now, let me tell you, this test includes section 6.1 and 6.3, which were done before spring break. So if you are trying to look for notes, you have to look in the other packet for 6.1 and 6.3. Okay? But the review is a separate sheet. Review is a separate sheet, and I gave it to you maybe on Wednesday, maybe on Thursday.
The day you were not here.
Huh?
The day you were not here.
No, I gave it to you before that. So, anybody know what number 1 is?
Rhombus.
It is not a rhombus. Rhombus looks like a slanted square.
That's a slanted square.
I don't think so. I would say it's more like a slanted rectangle, which makes it a, anybody?
Parallelogram.
Parallelogram. What is the formula for the area of a parallelogram? Should be small b times the height, where the base and the height have to be perpendicular to each other. Do you need a new review, Sean? Was there another one back there, Blake? Okay, just to the right of the black crate. So area is equal to, what is my base here? What is the base? 9.9. Good. Times, what is the perpendicular height to that base? 4.6, right? So multiply those two together and tell me what you get. Did you find it? Where's your review? Did you find it? That's not it.
Yeah, I know.
What'd you get?
I got 45.4.
That is correct. 45.54. How am I going to label this?
We'll say,
Miles.
yeah.
And since it's area, not cubed,
Square.
squared.
Yeah.
Right? I know, we're in volume. We've been doing volume for a while now. Okay. So there's the first one. All right, number 2. What kind of a figure is that? Alex, what kind of figure does that look like? Do you remember? Somebody help her out.
Which one?
Number 2?
Uh,
The one after number 1?
kind of looks like a shoe.
Shoe is not a good mathematical term, though. Guys, come on. What is that?
A rhombus?
No. You just like rhombus, don't you?
Yeah.
That is a trapezoid. Trapezoid. Trapezoid has the 2 bases, base 1 and base 2. And the formula for the area of a trapezoid is 1/2 times the height times the sum of the bases. So we need to, according to order of operations, add the bases together first. So my numbers are going to be 1/2 times 3 times 1.5 plus 5.7. If you do this on a calculator, you need to make sure you include the parentheses when you're adding them together. Or add them together first and then multiply. So 1/2 times 3 times 1.5 plus 5.7, what are you going to get? Come on, people. Everybody should be putting these in on the calculator. Ontario, put that away, please. These are the answers.
What?
Not in any specific order, but these have the answers so you can check and make sure you're getting a correct answer.
Ooh. Can we use this on the test?
No, it won't help you on the test. Guys, when you multiply those together, what are we getting for an answer?
Can't read that.
1/2 times 3 times quantity, 1.5 plus 5.7. Huh? I can't.
1.5 times.
Plus 5.7. Yes, 10.8 what? No. Meters squared. Always need to be labeling when you're talking about area and volume. Okay? All right. Now, what is this next figure? What is that? What's it look like? Kite. Yes, that is a kite. Also known as a diamond. A diamond is not the mathematical term, but we use that to help us figure out which formula to use. Remember, shine bright like a diamond. We've got the D. So what formula has the D in it? Come on, look at that formula page. It's a half sheet or it's on the last page of this review. They're at the very top of the half page. Which one has D in its formula? 1/2 times the length of diagonal 1 times the length of diagonal 2. So 1/2. This 12 and 3, are those the lengths of the diagonals? Yeah. So here's diagonal 1 from one opposite vertex to the other opposite vertex. And it says that is 12 times diagonal 2 is this distance, which goes and is 3 miles, so times 3. So if you put that together on the calculator, 1 divided by 2 times 12 times 3,
It's
18 miles
squared.
squared. Perfect. Okay. Any questions on number 3? Those are the diagonals from one opposite vertex to the other opposite vertex. All right, what is number 4? We haven't talked a lot about number 4.
A rhombus.
It is not a rhombus. A rhombus has all sides that are the same length. What is that? It is not a square. It is a rectangle, yes. It is a rectangle. And we have not talked about a rectangle a lot, but maybe you remember it from previous years, previous math courses. What is the area of a rectangle?
Length times width.
Yes, length, that's an L, times width. And your length and width have to be perpendicular, which they are. So multiplying 11 times 5, what do we get?
55.
55 what?
Square
Square
inches.
meters. Or meters squared or square meters. I would take either. Ooh, guys, that was pretty rough. These are the easier shapes, so hopefully we can get some momentum going. Any questions on these 4, though?
Nope.
All right, let's go to the next page. 3-sided figures. Oh, what do we call those?
Circle.
No, come on.
Triangle.
Yes, triangles. All right, triangles is another one that we haven't talked a lot about. The formula is not up there, but kids really do have difficulty remembering them. Area of a triangle is on the front board here. It's 1/2 times base times height, where your base and your height have to be perpendicular. So 1/2 base times height, and they have to be perpendicular. So what is my base for this first figure? 1/2. What's the base? Five, yes. Now you're like, well, that's not the bottom. Well, if we rotate it, it could be the bottom, right? So that's 1/2 of 5 times, what is its perpendicular height? 3.1. So you have to recognize the formula and put the numbers in. So area is 1/2 of 5 is 2.5. 2.5 times 3.1, or you just multiply together. 1 divided by 2 times 5 times 3.1, and what do we get? Say it. Somebody started to say it. 7.75 inches squared. Okay. So everybody see how we're doing these.
Yeah.
Now, what is number 6? What is that figure?
That's so hard.
A 3-sided figure? Still a triangle, right?
Yeah, that one.
Okay, so area of a triangle is 1/2 times the base times the height. As long as the base and height are perpendicular, you're fine. So what is my base?
This is confusing. I mean,
Well, take it and rotate it so it's on the bottom, if that helps.
is it 5?
It could be 5, it could be 4. It really doesn't matter. It depends on how you turn it. So if I have a base of 5, what's my perpendicular height? 4. If I have a base of 4, its perpendicular height would be 5. So it does not matter.
Yeah.
So half of 5 is 2.5, and 2.5 times 4 should give you 10 miles squared. Area is 10 miles squared. Any questions about those two? Okay, let's go to the next one. What is number 7? What is that shape? It is a circle. Now, am I trying to find a sector there, or am I just trying to find the area of the circle? Yeah, so area of a circle, what is the area of a circle?
3. 360? Wait,
Pi?
yeah, 5 times.
Look on your formula sheet. Mm-mm. This is just area of a circle
Oh,
with a radius given to you. So this is just your radius. I just want to know what's the formula for area of a circle? Pi r squared, yes. So area is pi times my radius, which is 10 squared. 10 squared is 100 times pi. So that should give me, multiply it on your calculators. Should be 314.15. Now, it says round to the nearest tenths place. Which digit is in the tenths place? Yes, the 1 to the right of the decimal point. So I look next door, 5 or more, that 1 is going to go up. So my correct answer should be 314.2
wait, this thing.
kilometers squared. Yes.
How do you put this one in the calculator?
Pi
Okay.
times 10, and then hit x squared, and then enter. Did you get 314.2? Pi button times 10, and then hit the x squared button and enter.
Still giving me 100.
You're not hitting pi at the beginning. Pi times. When does this end? 45. All right, so I need you and would like for you to try to keep working on this. This next one is the area of a sector. Did you still get 100? Bring it up here and I'll show you. Area of a sector is degree out of 360. Remember, this is like my slice of pizza times pi r squared. Okay, come over here and show me what you are pushing or putting in. Pi times, whoa, was it 10? Okay.
And see.
Mm-hmm.
No, it's enter.
Okay. Well, it's giving you 100 pi, but then you need to hit
Oh.
that button to get the decimal.
Okay.
Okay? All right. Okay. So we will stop there for today. Try to do as many of these problems as you can. That little sheet that I gave you, that is an answer sheet. You can be checking the answers off. Now, it's only for the problems that have numbers as answers, okay? It is not for describing the shapes. All right? So that is for like problems 1 through 13 and number 17. Okay? So we will continue with this review. Please work on any missing assignments. Work on this review a bit more. Okay? I am wanting everybody to do as best they can on this second to last test for this semester.